Guys, I hope you are fine. Me too, I'm fine. So today guys, welcome to my lesson, and I start off with reading the question. The mean diameter of a sample of 400 rollers is 2250, that is 22.50 millimeter, and the standard deviation is 0.50 millimeter. Rollers are acceptable with diameter 22.36 plus or minus 0.53. Determine the probability of any one roller being within the acceptable limits. So guys, we use those two graphs. One of them is, I will standardize it, while the other one is for the normal curve. And so guys, or normal distribution, I will come and say that the sample is 400, 2250 is the mean diameter. So here we shall have 22.50 as our mean diameter. Maybe I may not write millimeter as of now, but we shall write it later. From there, the standard deviation we have, maybe I can also write them here, that the standard deviation is 0.50 millimeter, and the mean, I can write it also here, 22. Guys, I have blocked you. 22.50 millimeter, like that. Then we continue. Rollers are acceptable within diameter of 22.36. For 22.36 is around this point. Around this point because it has not yet reached 22.50. So around this point, guys, we have, maybe I can write it here, 22.36. And then we are told the allowable limit is 22.36 plus or minus. So guys, we look for plus, which is this side. That will be 22.36 plus 0.53. So here we shall have now 22.36 plus 0.53. Let me just calculate that one. 22.36 plus 0.53. That gives us 22.89. So at this point we have 22.89. That is plus 0.53 as we have seen there. Then let's now go to negative or minus 0.53. This one now is going to be somewhere here, guys. So let's calculate that. This one is going to be now 22.36. That is 22.36 minus 0.53. So that one comes to 21.83. So this one is 21.83. So that is our now limits. We have limit 21.83 up to 22.89. And then the question, determine the probability of any one roller being within the acceptable limits. So now, guys, we come to this standardized form, whereby we have, at the center we have 0. In other words, the mean is supposed to be 0 for the standardized form. And so, we come and use our equation, guys. And this is our equation. That is Z equal to X minus mu all over standard deviation. So now we are going to convert 21.83 and 22.89 into standardized form. So this one is going to be Z, let's say Z1 for this side of that is 21.83. We say this one is Z1 like that, and this one we call it Z2, that is for 22.89. So we first of all go for Z1. So for Z1, this is going to be X. Z1 is 21.83 minus the mean all over the standard now deviation, which is 0.50. So Z1 is going to be, using the calculator, it's going to be, now let me just write it, 21.83 minus 22.50 equals to that. That is negative 0.67 now divided by 0.5. This gives us negative 1.34. So guys, we have negative 1.34. That is for Z1. So this one is negative 1.34. But we don't have to put the negative because negative shows it is on the left side. We go to Z2. Z2 is going to be 22.89 now minus 22.50, just as we have done formerly. We now divide by 0.50. So this one is going to give us, so we can check, 22.89 minus 22.50, 22.50. This is equals to that, now divided by 0.5 equals to 0.78. So this is 0.78. Now guys, we have converted. So this one is 0.78. What we require guys is now the probability. Because the question asks, determine the probability of $1 being within acceptable limits. So this is what we are now looking for guys. So we would have to check from the table for each of the following, 1.34 and 0.78. We said this one we consider it as, because the table does not have negative, now we consider it as 1.34. So I will say for Z, that is probability of, that is, okay, I can call it negative in that I'm writing now here. So this one will be negative 1.34, like that, greater or less, x is greater or same as 1.34, and then like that, then 0.78. Note I have put it in negative form, but for this one, you don't have to put in negative form when you are looking for the probability there. So this is now what guys we are looking for, because this is also equal to probability between 21.83 like that, and 22.89. That one is actually equal. And so, as we have said, this is what now we are looking for. So now we go to our standard table and let's check for probability that is at 1.34. We see now the area, that is this area, from here to this point. So the area is going to be, here I have the table, that is now 1.34 negative, or this one does not have a negative, you still use the positive, 1.34. So this one is supposed to be at this point, 1.3, then you come to 4. This is now what we require, guys, here. Here I can lift it so that you can see it. So that one, that is, this is actually 0.4099. So that is 0.4099, like that. This one, of course, is the, you can write it like that, negative, like that. Then we go to the next one, P. Maybe this one I write it like this, 0.78. 0.78. Now we check it again and see what we get. And this is where we come now for 0.7. This is our 0.7 here. Now we go up to 8, where 8 is here. So 0.78, we move like that, like that, like that, until we come now to 8. I hope this is this. Okay. This is 0.2823. 0.2823. So we write there 0.28, 0.2883. So 23. I beg your pardon. 23. So this one now is what we are looking for now. So this one now you can come up and add. So this will be 2. And this one is going to be 2 again. This one is going to be 9. And then we have 6 here, like that. So this, guys, is now going to be the probability we are talking about here. We are saying determine the probability of any one dollar being within the acceptable limit. So that is our probability. That is 0.6992. So guys, thank you for listening to me and see you next time. Bye bye.